Hey there guys, welcome back to another video, and if this is your first time here and you want to get the best grade possible in maths, start now by subscribing and clicking the bell. There is lots of useful content coming your way. Okay then, so in this video I've made a PDF of GCSE 9 to 1 maths past paper exam questions on iteration from AQA and Edexcel. If you haven't watched this video yet and you need to know what iteration is and how to do it really easily on your calculator, go there first, watch that, come back and do these. So you can get this PDF down below in the description. If you want any particular topics done like this, let me know down below in the comments. Okay, let's go. And first up, so we are just generating terms in a sequence, not solving an equation. So a sequence of numbers is formed by the iterative process. U n add 1 is equal to 3 over un add 1. So the next term is made by calculating 3 over the last term add 1. So u1 is equal to 4, and our job is to work out the value of u2 and u3. So again, we can use our calculators to make this really easy. So put 4 into your calculator, press equals. Now we put in the formula. So wherever there is a un, we press ans. So you then want to put into your calculator 3 over ans add 1. And then if you press equals, you should get 3/5. So that's u2. Press equals again and you should get 15/8. Cool. Okay, next up, using x in add 1 is equal to -2 minus 4 over xn squared, and with x naught as minus 2.5, part A, find the values of x1, x2 and x3. Okay, so we do need to be a bit careful when negatives are involved. So start the same way as always, put minus 2.5 into your calculator and press equals. Now when you try to put in minus 2, it's going to put an ans before the minus 2, or mine does anyway. So you need to go back and delete that. So just press down and then put in minus 2 minus 4 over ans squared, press equals, and for x1 we should get minus 2.64. Press equals again. x2 is, if we go to 4 decimal places, it's minus 2.5739. And press equals again for x3, and we should get minus 2.60 3, 8. Okay, then for part B, we want to explain the relationship between the values of x1, x2 and x3 and the equation x cubed add 2x squared add 4 is equal to 0. So remember that I mentioned in the previous video, iteration is a method to solve horrible equations. Now, to turn an equation into an iterative formula, we try and get an x on its own. So, if we look again at the iterative formula, which is x n add 1 is equal to minus 2 minus 4 over x n squared, can we turn the equation down here into something that looks very similar? So, can we get an x on its own with a minus 2 minus 4 over x squared on the other side? So, if we start then with x cubed, add 2x squared, add 4 is equal to 0. We can, first of all, subtract 2x squared and subtract 4 from both sides. So x cubed is equal to minus 2x squared minus 4. So that's starting to look familiar because we have a minus 2 and a minus 4. Now to get from x cubed to x, we have two options. We could cube root, but that's not going to make it look as it does above. What we're actually going to do is divide through by x squared. So we're going to get x is equal to minus 2x squared over x squared. That's just minus 2 minus 4 over x squared. So that is where the iterative formula comes from. So the x on the left becomes x n add 1. And the x on the right becomes xn. So xn add 1 is minus 2 minus 4 over xn squared. So that means then that x1, x2 and x3 are estimates of solutions to x cubed add 2x squared add 4 is equal to 0. Or we should say approximations. So, what that means, they are approximations of x values that make that expression equal to 0. Okay, next up, for part A, we want to show that the equation x cubed add x is equal to 7 as a solution between 1 and 2. So that means there should be a value somewhere between x equals 1 and x equals 2 such that x cubed add x is equal to 7. So what we're going to do is substitute in x is equal to 1, see what we get. Substitute in x equals 2, see what we get. Now, if this is true, one of the values that we get will be less than 7. One of the values we get will be greater than 7. So, when x is 1, well, that gives us 1 cubed add 1. One cubed is 1, add 1 is 2. When x is 2, two cubed add 2 is, well, 2 cubed is 8, add 2 is 10. So 2 is less than 7, 10 is greater than 7. If you like, let's show you what's going on. So imagine this is the line y equals 7. Now, here's our curve. It's going to look something like that. Now, we've just shown that when x is 1, our value is 2, and when x is 2, our value would go across to 10. Now what we're going to be doing is trying to find the solution to this equation, so we are going to be looking for the x value of that point there. Okay, then part B wants us to show that the equation x cubed add x is equal to 7 can be rearranged to give x is equal to the cube root of 7 minus x. So again here we are finding an iteration formula. So notice that we want a 7 minus x. So we are going to go from x cubed add x is equal to 7, we're going to subtract x. So we get x cubed is equal to 7 minus x. And then we're going to cube root both sides. So we get x is equal to the cube root of 7 minus x. Okay, then part C, starting with x naught equals 2, use the iteration formula. Xn add 1 is the cube root of 7 minus xn 3 times to find an estimate for a solution of x cubed add x is equal to 7. So, into your calculator, put 2 plus equals and then you want to put in the cube root of 7 minus answer, press equals, then we will get x1 is equal to at 5 decimals 1.70998. So I know here it doesn't say to a specific number of decimals. I always think 5 with iteration is a good number. Also, here it doesn't say find x1, x2 and x3, but when in Rome. So press equals again, and we're going to get x2 is 1.74242. One more time, and x3 is 1.73885. Cool. So that would be our answer to part C. Now while we're here, I'm going to chuck in an extra part. We are going to test whether this is a good estimate. So, what we're going to do to check this is substitute this value of x into x cubed mod x. What we should get, if it is a good estimate, is an answer very close to 7. So, when x is 1.73 885 x cubed and x is 6.9964. Now that is incredibly close to 7, so what that means is we have a good estimate of the solution to the equation. Okay, next up, an approximate solution to an equation is found using the iterative formula xn add 1 is equal to xn cubed minus 2 over 10 with x1 equals minus 1. Part A. Work out the values of x2 and x3. So, put minus 1 into your calculator, press equals. And then put in answer cubed minus 2 over 10, and you should get x2 is equal to minus 0.3. Press equals again, and we will get x3 is minus 0.2027. Cool. And then part B wants us to work out the solution to 5 decimal places. So, when they ask something like this, just keep pressing equals until your calculator shows you the same thing every single time. So, do that, and we should get x is equal to minus 0.20081. Cool. Okay then, last one. Part A, show that the equation x cubed add 7x minus 5 is 0 as a solution between x equals 0 and x equals 1. Okay, so we had a very similar question back along. This time then, if there is a solution between x equals 1 and x equals 0, when we substitute in these values, 1 should give us a negative answer and 1 should give us positive. So, when x is 0, we get 0 cubed add 7 times 0 minus 5 and that is just going to give us minus 5. When x is 1, we get 1 cubed, which is 1, add 7 times 1, which is 7, minus 5, so that's 8 minus 5, which is 3. Okay, so that change of sign tells us then that somewhere between x is 0 and x is 1, there is an x value. That makes x cubed add 7x minus 5 equal to 0. Okay, then part B wants us to show that x cubed add 7x minus 5 can be written rearranged to give x equals 5 over x squared add 7. Okay, so we want 5 on top of this fraction, so a good first move would be to add 5. Okay, so on the bottom, we want x squared add 7. So at no point in this are we cube rooting. So what we need to spot is on the left there is a common factor of x. So we can factorize. So we get x times x squared add 7 is equal to 5. We then divide through by the bracket and we get x does indeed equal 5 over x squared add 7. So that is where our iteration formula comes from. Okay, then for part C, starting with x0 equals 1, use the iteration formula. Xn add 1 is 5 over xn squared add 7. 3 times to find an estimate for the solution of x cubed add 7x minus 5 equals 0. Okay, so put in 1 plus equals. You then want to put in 5 over odds squared add 7 plus equals, and we get x1 is equal to 5x, which is 0.625. Press equals. x2 is 0.67653. Press equals, and we get x3 is 0.67045. So that would be our estimate. Okay then, for the final part, by substituting your answer to part C into x cubed add 7x minus 5. Comment on the accuracy of your estimate for the solution to x cubed add 7x minus 5 is equal to 0. Okay, so when x is equal to 0.67045. If that is good, then we need x cubed add 7x minus 5 to be very close to 0. So we get x cubed add 7x minus 5 is equal to minus 5.5 with a lot of other decimals that don't really matter, times 10 to the minus 3. Now that means then minus 0.0055. Now that is a very small number, which is why the rest of the decimals don't really matter. So it's a very small number, it's very close to 0, which is what we wanted. Therefore, we would say our solution is quite accurate and reliable. Okay guys, that's it for this video. If you found this useful, don't forget to subscribe. If you want particular topics done like this, let me know down below in the comments. Take it easy, take care.